In this video, we're going to talk about some of the properties of logarithms. There are three different properties that logarithms have that we're going to talk about in this video. And in this video, I'm going to kind of just introduce them to you and talk about how to use them, but we're not really going to prove them. We will prove them later. Right? But it turns out that there's three special properties that happen with logarithms. All right, let's take a look at these three examples. All right, so this first example, I've got log base 2 of 3 plus log base 2 of 5. Right, so we're kind of asking the question, what happens when I add two logarithms that have the same base? Right, and you might think, oh, 3 plus 5 is 8, so this must be log base 2 of 8. But actually, that's not what happens. And it turns out that if you add these two logarithms, you actually get log base 2 of 15. Right? This 3 and 5 actually multiply to get this 15. Right? And we'll just hold on to that thought for a second. Right? What happens when I subtract two logarithms? Right? If I have log base 10 of 8 minus log base 10 of 2. Right? And you might think, oh, 8 minus 2 is 6. But that's not actually the way this works. Log base 10 of 8 minus log base 10 of 2 is actually log base 10 of 4. Right? And you might think, oh yeah, it's 8 divided by 2. Okay? All right, there's one more kind of special property. If I have 2 times log base 3 of 5, this is actually equal to log base 3 of 5 squared, or 25. Right? So three kind of interesting properties, and these logs kind of behave in ways that you wouldn't normally expect. Right? When you add these two logs, it's actually log base 2 of the product of these numbers, 3 times 5. Right? When you subtract two logs, you're not actually doing 8 minus 2. You actually get the log of the quotient, 8 divided by 2. Right? And here, this 2, we can use that as an exponent. Right? We can say 5 squared is 25. All right, so here's the formal statement of these properties, right? So if I have, these are three properties. So if I have log base b of x plus log base b of y, that's equal to log base b of x times y, right? And if I have log base b of x minus log base b of y, that's equal to log base b of x divided by y. Right? And if I have the last property here, y times log base b of x, that's actually equal to log base b of x to the y power. Right? So we can use this y as an exponent. Okay? So, and this is, again, it's kind of the interesting things that happen with logarithms. Right? So when you add two logarithms, it's actually the logarithm of the product of these two numbers here. Right, when you subtract two logarithms, it's actually equal to the logarithm of the quotient of these two numbers. Right, and the last one, when you have this number here that's being multiplied times this logarithm, you can actually raise, that's equal to this log, where this x is raised to that y power. All right, so I'm not going to prove these to you, but I want to demonstrate to you that they work. Okay, and we'll prove them later, but I just want to give you three examples to show you that these do in fact work. Okay, so take a look at this first one. Log base 2 of 4 plus log base 2 of 8. Well, according to the properties I just showed you, this should be equal to log base 2 of 32, right? Because 4 times 8 is 32, right? Is that true? Let's think about that. Is that true? Well, we know these logarithms. What's log base 2 of 4? Well, that's 2, right? Because 2 squared is 4. And then what's this one? What's log base 2 of 8? Well, that's 3, because 2 to the third power is 8. Right? And is that equal to log base 2 of 32? It is. Log base 2 of 32 is 5, because 2 to the fifth power is 32. Right? So this is true. Okay? And again, I didn't prove it to you. I just showed you one example of how that's true. Okay? Well, let's look at another one. So I have a subtraction one. If I have log base 10 of 1,000 minus log base 10 of 10, well, according to the property, right, this should be equal to log base 10 of 100, right, because 1,000 divided by 10 is 100. right? I don't actually subtract, right? This is equal to this log, right? And let's think about, is that true? Well, we know these logs. What's log base 10 of 1,000? That's 3, because 10 cubed is 1,000. And what's log base 10 of 10? Well, that's 1, because 10 to the first power is 10. And then what's this side? Log base 10 of 100? Well, that's 2, because 10 squared is 100. Right? And again, this is true. 3 minus 1 is 2. Let's look at one more. 2 times log base 2 of 8. Well, according to that property that we talked about earlier, this should be equal to log base 2 of 8 squared. Right? And that seems so weird, but let's see. Is this true? Okay, well, let's look at this side. 2 times log base 2 of 8. Let's see, I can rewrite that as 2 times, well, log base 2 of 8, that's 3. So this should be equal to 2 times 3, which is 6. Right? And is that equal to what we have on the right-hand side? Right? Log base 2 of 8 squared. Well, that's the same thing as log base 2 of 64. Right? And log base 2 of 64 is, in fact, 6, because 2 to the 6th power is 64. Right? So again, I didn't prove these to you, but I showed you an example that these are, in fact, true. So these, again, just to summarize, these are the 3 properties that you need to know. Right? When you add 2 logarithms, it's actually equal to the log of whatever base you have of the product of those 2 numbers. Right? And when you subtract 2 logarithms, that's equal to the log base b of the quotient, dividing these 2 numbers here. Right? And then last property, when you're multiplying times this constant here, you can use that as an exponent. All right? We're going to do some more with these properties in a little bit.